All right, AP Physics. This is Mr. Robbins, and I regret to tell you that I have COVID. I tested positive, which means I will not be present with you guys for 4 more school days. I'm hoping that I'll be able to be back on Tuesday. I'm just waiting to get confirmation about that. So I have a couple announcements for you today. You guys will be working without me for a while here, which is a bummer because I love this first unit when you're drawing motion diagrams and figuring out how things move, and we get to demonstrate some things in class. So hopefully I'll still do that stuff when we get back. But I want you guys to try to continue to move forward a little bit without me there. And I'll talk to you about what the next 4 days will look like and how I'm going to help you with that. The first thing is all due dates are going to be after I return. I don't want any of you stressed out about not knowing how to do something and not being able to get help from me. So I will not have anything collected until after I return, so you have the opportunity to ask questions in person to me. That being said, as we do new stuff in the classroom, please keep up with it so that you're not overwhelmed when I get back and you do have due dates for these things that you've had time to work on. So email me if you do have questions between now and then, and I'd be glad to answer those things over email that I can. And if I can't answer over email, sometimes it's better to draw a picture or to write out the math or something else like that. If I can't answer over email, I will make a video to help answer it and send it to you. Just a reminder, your 2 main assignments that are out right now are the Wolfpack 500 and the Chapter 1 packet that you got yesterday. And the Chapter 1 packet will take you some time to complete. Hopefully you got a good start on that and you're able to read your textbook to help work through that a little bit. The next 4 days, what you're going to see from me are posts on Google Classroom with videos walking through the content that I would normally walk through as a class. And I'm not going to have you guys watch that as one big class because personally, as a student, I enjoy being able to watch a video at my own pace. And if I'm taking notes, I can pause it when I want to, re-listen to a part if I need to, or if I'm bored with it and honestly it's going slower than I think it needs to, and I understand a lot of it from the chapter reading or something else like that, I'll play it at 2 times speed and just buzz through it. And I want you to have the opportunity to do that as well. So I recommend bringing a set of headphones tomorrow and the next couple days while I'm gone, so that you can listen to those videos on your own Chromebook and go at your own pace and listen to the ones that you need to. So please bring that starting tomorrow. If you don't have a set of headphones, I will have the library set dropped off in the classroom so that you can use those. The only other thing I'll give you today, before I go on to the next little thing, I'll also post one video today on Google Classroom that will help you walk through motion diagrams, just the start of them, and then look to see additional videos posted on how to do velocity vectors, position vectors, and acceleration vectors. And I'll try to break those up into smaller videos so that you can just find the one that you need to listen to and go back to that one if you need to. Here's your only thing today from me with this main video. Go ahead and work through this with a partner. You can pause the video here. There's 3 motion diagrams shown, which is a dust particle settling to the floor at constant speed, which is a ball dropped from the roof of a building, and which is a descending rocket slowing to make a soft landing on Mars. Hopefully you paused the video and had a chance to talk with a partner about your answer. I want to point out one thing with your motion diagrams. All of them are labeled with 0 on your first particle or first point, and then going forward 1, 2, 3, 4, progressing. When you're making your motion diagrams, you should be doing the same thing in your packet, labeling your first one, and then moving forward. Hopefully you chose this. B is your correct answer. A is the ball dropped from the roof of a building. It starts out slow and gets progressively faster, greater distances between each time interval. B is the dust particle dropped, settling to the floor at constant speed. So it's equal distance between each one. And then your rocket landing starts out fast as it's dropping down and then incrementally gets slower and slower. Okay, hopefully you're able to figure that out. If you were, you're probably understanding motion diagrams correctly. The last thing I'll leave you with, your Wolfpack 500. If you flip to that sheet, I want to point out a couple things for you. For number 1, hopefully you're starting to think about this in terms of motion diagrams now. And the stuff that we're setting up right now, you might be thinking, I thought that AP Physics was going to be a lot of math and stuff like that and equations. And it will be. We'll have equations and math to apply to problems. But conceptually, this first little unit is about building the framework for understanding motion. And one of the best ways to do that is to walk through the motion diagrams that we've been doing. So if you think of number one here, your average speed being 3 meters every second you're going to travel 3 meters. So after 1 second, you'll go 3 meters, 2 seconds will be 6, 3 seconds will be 9 meters. And you can think about that now in terms of a motion diagram. A 0, a 1, a 2, and we would have to go all the way to a 3 now. For 3-second intervals, the first interval will be right here, the second interval will be right here. The reason I'm drawing this out for you is because I want you to see how to draw the position vectors here and label our little diagrams. When you get to this point in your little packet, to get velocity vectors, all you're going to do is connect your dots and throw a little velocity symbol over it. And you're going to call this V1, V2, V3, and you'll work your way across. I'll make a little video separately for that, but you're starting to think about motion like this. Number 2, must the calculated average speed also be the maximum speed? Hopefully you said no, and you have an explanation. If you didn't say no, try to talk to someone in the class that said no and see why they said no. Number 3, describe a technique to determine the maximum speed reached during a race. You should be thinking about smaller and smaller time intervals for this. And if you want to know the exact maximum speed, you should start thinking like the time interval gets infinitely small. So you're taking infinite measurements of time as that person runs through that race. Okay. If you haven't finished your Wolfpack 500, make sure you do so. Okay. And I'll end with this, just a little precursor to the rest of the course. We are starting out studying linear motion. This is what we'll do first. And then we'll look at circular motion with kinematics. All of this is just going to be describing motion. How does one thing move from point A to point B or around a circle, and how we predict how that moves. We'll do the same thing with projectile motion, and then eventually with rotational motion, a whole body moving. Instead of just one object moving, we'll talk about that whole body or the whole Ferris wheel all at once. And eventually we'll break down all of these guys and determine why they move the way they do based on forces. And this is a great quote. Every year I mention this. Albert Einstein says, physics should be as simple as possible, but not any simpler. And it's a funny quote. You can laugh at that, but it's so true. We will try to simplify things as much as we can with models and diagrams and things like that, but we can't be so simple that we miss the way that the object actually moves, or we miss a way to describe how that motion actually plays out in the real world. So that's what we're going to be working through with physics. Please email me with questions if you have any, and look on Google Classroom because I'll post the first little video walking through motion diagrams today.